Hey everyone, I hope you guys are doing well today. Make sure you are watching this video all the way through because we're going to start talking about our exponent rules, and these are some important things that you need to know going forward that we will be using and we will be talking about a lot. So today's question is, how do we use negative and zero exponents? What do they mean for us in terms of expressions, and how do we simplify expressions with them in them? So let's start with negative exponents. So for every non-zero number a and an integer n, a to the negative n equals 1 over a to the n. So when we see negative exponents, okay, really we just need to think about them as a notation. Okay, they are another way to express 1 over, okay, that base, okay, written to its positive power. Now n, remember, is just an integer. I know that sounds fancy, okay, but remember it's just your counting numbers plus 0. So 0, 1, 2, 3, 4, 5, and their opposites, negative 1, negative 2, negative 3, negative 4, and so on. Non-zero number a, this just means that a, right, cannot be 0. Right? We cannot be dividing by 0. Right? So what this could look like, it could look like as a number, 7 to the negative third, okay, raised 7 raised to the negative third power, which is the same as writing 1 over 7 to the third, or negative 5 to the negative second, which is 1 over negative 5 to the second. So what's important here to notice is that this negative 5 is in parentheses. That entire quantity is being raised to the negative second power. So when you take it to the denominator, all you need to make sure it stays in parentheses so that quantity is being squared. Another example could be if you had x to the negative fourth, okay? So anytime we're writing our expressions, we want them to be simplified. They have to have a positive exponent. When we see this negative exponent, we know when that negative exponent either needs to move places, so this guy needs to move down to the denominator so that it becomes positive. Our numerator is really 1. This guy is the same as 1 over x to the fourth. Okay, so our negative exponents are really, okay, just a way for us to express a fraction with an exponent in the denominator. So what's the simplified form of each expression? So let's look at number 1. We have 5a cubed b to the negative second. So when I'm doing these problems, I like to work number by variable by variable. So my 5, I can see here, has no exponents. So my 5 is going to stay exactly where it is. Okay. My a cubed has a positive exponent. I can't simplify it further, so it stays in the numerator, a cubed. But my b has a negative exponent. And if I want that to be simplified, in order to get that exponent to be positive, I'm going to send my b to the denominator, and the exponent becomes positive. So my final answer is 5a cubed over b squared. Similarly, okay, with number 2, we have 1 over x to the negative fifth. Well, right now, my negative exponent is in the denominator. So if we want to get it to be positive, in this case, we do send that x to the fifth to the numerator. So this is really x to the fifth. And the reason this works is if we think about x to the negative fifth as 1 over x to the fifth, we could rewrite this expression as 1 over x to the fifth. Well, dividing by a fraction is the same as multiplying by its reciprocal, and we talked about that the other day with solving equations. So this is really 1 over x to the fifth times x to the fifth over 1, which is really just x to the fifth. So again, your negative exponents are notation, okay, to represent, most of the time, having an exponent in your denominator. Okay. Now we also have zero exponents. So again, we have our non-zero number a, right? That just means a is not 0. The a to the 0 is equal to 1. So any number, any variable raised to the 0th power is always going to be 1. So here we can see that 4 to the 0 is 1, negative 3 to the 0 is 1, 5.14 to the 0 is 1. It doesn't matter if it's positive integer, negative integer, or even a decimal. If we raise any number that's not 0 to the 0th power, it is going to be 1. Okay, and same stands for our variables. Even if we used m to the 0th power, this is still going to be 1. regardless of what m is, as long as it's not 0. So now when we do this, we need to be careful to identify what's being raised to the 0th power. So in this first expression, 3x to the 0, okay, we notice, okay, that 3 is not being raised to the 0th power. Okay, so your 3 does not automatically become 1. It stays as part of your answer. So it's 3 times x to the 0. Well, x to the 0 is 1, so this is 3 times 1, which is just 3. However, if we notice in number 2, we have these parentheses. What that means is that whole quantity, negative 8 to the x, is being raised to the 0th power. So that entire quantity becomes 1. Okay? It's important that we distinguish between the difference between 1 and 2. In 1, only that x is being raised to the 0th power, so only that x becomes 1. We still need to multiply it by 3. And in that second one, that entire quantity is raised to the 0th power, so it all becomes 1. If you have any questions, make sure you make a note of it and ask in class. Have a good day.